Hey, what is going on, guys, and welcome back. In this video, we are continuing with chapter 5, and we're covering the last section in chapter 5, and we're going to be learning about tuples, which is another data type in Python. It's also pretty common in other programming languages. So we're going to learn about that, and we're going to do all the exercises. Hopefully, we can knock out all the content and exercises in this one video, because there's only 5 exercises to do, and quite a bit of readings. The last 2 exercises are a little bit on the larger side, or longer side, I should say, but the other 2 are, out of the 3, are pretty simple. So we'll try and go through those pretty quickly and hopefully get through all of the material and content in this one video. So the learning objectives are that after this section, you'll be familiar with the tuple data type. You'll be able to create tuples from various types of values. You will know the difference between a tuple and a list, and you'll be able to name some typical use cases for tuples. So tuples is a data structure which in many ways is similar to a list. The most important differences between the two are that tuples are enclosed in parentheses, while lists are enclosed in square brackets. So if you give me 1 second here. So as we've learned in Python, if you wanted to create a list, we'll create a variable like this, my list, set that equal to these opening and closing square brackets. So our list can contain numbers, strings, can contain floating point numbers, right? But tuples are done like this. So we can do this, etc. So we'll learn more about how to structure tuples but in depth as we continue with the reading. But as you can see, with lists, we have our content encompassed or wrapped with these square brackets. We have an opening one and a closing one. And tuples are encompassed with regular parentheses, right? So we have an opening and closing parentheses surrounding our content. So the following bit of code creates a tuple containing the coordinates of a point. So here we have a variable called point, which is assigned this tuple, opening and closing parentheses, and we have 10, 20. The items stored in a tuple are accessed by index, just like items stored in a list. So here, again, we have our variable point, which is referencing this tuple of a coordinate point, 10, 20. And if we want to print the x coordinate, we do point using square brackets. We can target the first item in the tuple, and so index 0 and index 1 will target the second item in the tuple, and we can print them like such. So when this code is run, it will print x coordinate is 10 and y coordinate is 20. The values stored in the tuple cannot be changed after the tuple has been defined. The following will not work. So we can't overwrite the content of a tuple. We can't create a tuple, point, set that equal to our coordinates 10, 20. We can't update what the first item in the tuple is, like this, using square brackets, as we've done before in lists. Because with a list, like over here, I can say my list, right? Let me print my list. So you can see the original one. Then I could say my list 0 is equal to 1, and then print my list again, right? And so let's run this. You can see originally our list had 0, 1, followed by the string, and then followed by the floating point number. But we went in this line, and we decided we don't want the first index of the list to contain the number 0. We wanted to contain the number 1. So we said my list at index 0 using the square brackets, change that to 1. And now when we print my list, it has 1, 1, followed by the string, and then the floating point number. So we can't do that with tuples. I can't say my tuple 0 is equal to 1 like that. That's not going to work. And if I run this, we're going to get the same error. Tuple object does not contain item assignment. So that's what this is telling you here, right? You can't spot change. You can't index change. You can't change the values at certain indexes in a tuple. So here we have our first exercise called create a tuple. It says please write a function named create underscore tuple, which takes 3 integers as its arguments and creates and returns a tuple based on the following criteria. The first element in the tuple is the smallest of the arguments. the second element in the tuple is the greatest of the arguments, and the third element in the tuple is the sum of the arguments. So if I was to call the create tuple function with the numbers 5, 3, and -1, then -1 is going to be the smallest, then 5 will be the second smallest, and then the third element is the sum of the arguments. So the sum of the arguments. So, okay, so it'll be, but we're calling it with this. So 5 plus 3 plus -1 will be 7. So when create tuple basically returns a tuple that is structured like this. The first element will be the smallest integer. The second element will be the second largest, and then the third will be the sum of the original arguments. So I have VS Code opened. I also have all the exercises that we're going to do in this section preloaded. So I'm just going to open the file here, and I'm going to copy this. I'm going to paste it in because we're going to use that for the test. Here I'm going to define a function called create tuple, which takes in these parameters x, an integer, y, an integer, and z, also an integer, and it returns a tuple. So we can just return like this, for example, x, y, z, right? But we're just going to have to figure this out. So we're going to say my tuple is equal to none. And then we're going to say if x is less than y, then my tuple is equal to x, comma y, comma x plus y plus z. And then else if, y is less than x, then we can say my tuple is equal to y, comma x plus y plus z. Else, my tuple is equal to z, comma. Oh, actually, hold on a second. Let me think about this for a second because z could be also smaller than x and y. So we need to say if x is less than y and x is less than z, then we can structure it this way. Y is less than x and y is less than z. Otherwise, we'll know that x, y, and then x plus y plus z. So let's return my tuple, and let's just see if this works. So I'm going to run the code. Okay, it worked. We got -1, 5, and 7. So let's run this. I think the test will still fail, but let's see. Okay, so we did fail. So, okay, so this is what I want. I want another test case. Okay, so what we are determining so far is which of the three parameters is the smallest. But we don't really do a good job of determining which one is the largest, right? Because remember, we're supposed to return. If I can go back to this, we're supposed to return the first element in the tuple is the smallest, the second is the greatest, and the third will be the sum. So what do we need here? Instead, what we could do is we could use some functions that we've learned about in the past. So we've learned the function min, we've learned max, and I'm pretty sure we've learned sum, but these three functions, what they will do is, given a set of numbers or a list, for example, they will determine what the smallest value is, what the largest value is, and what the sum of those numbers are. So we can actually take advantage of those and return our tuple. So what I'm going to do here is I'm going to say smallest is equal to minimum of x, y, z. Greatest is equal to maximum of x, y, and z. and then sum is equal to sum of x, y, and z. Oh, I'm sorry. Total, I should say, is equal to sum, because if I can't reassign. I can't call sum twice. So I can say just then return smallest, greatest, and then total. No. Or we just say x plus y plus z, just to be a little bit simpler. And then we just return this. So now when we run this, we should still get 157. And if we call it with this test case here, 100, 102, and 103, 100, 101, and 303, we get 504. But I don't know. It's not telling me what the return statement here should be. So let's send this solution to the server. Whoa, no, I did not mean to do that. Wait, let me rerun the tests. Okay, so the tests passed, so we know our code works. And so we can send that solution to the server and open the model solution in our browser. And there we go. So they did the exact same thing, right? They pushed a list to it. I think this why not the sum, when I called the sum function, didn't work because we didn't pass it as a list. In fact, I'm curious to try that. So I'll duplicate this and then wrap that in a list like that. And then like that, call the sum function. Yeah, so this will work. So now if I run this, we still get the same answer. So I like this even better. We can just reuse these three functions. So this will be the solution to our to this exercise. And again, just for testing purposes, let's see if wrapping this doesn't do anything. Okay, so which was what I remember from when we were first learning about these three functions. So you can pass it in integer numbers independently as comma separated values or arguments, or you can pass them as lists like this. So you can pass a list to the minimum, maximum, and sum functions respectively, and they'll do the calculations for you. So the minimum function will return the smallest value in a given list or a given set of numbers. The maximum will do the same, will return the biggest number in a list or a given set of numbers, and the sum will calculate the total of the values in a list, or and again, the best way to call it will be to using like this, passing a list instead of passing comma separated values as we could do for the minimum and maximum functions. So that's the solution to this exercise. You go back to the course website here, refresh, make sure you get credit for that. Okay, here we have another exercise called the oldest person, and we're instructed to please write a function named oldest person, which takes in a list called people, which takes a list of tuples as its argument. In each tuple, the first element is the name of a person, and the second element is their year of birth. The function should find the oldest person on the list and return their name. An example of the function in action. So here we have person 1, person 2, person 3, and person 4. Right? 1 is born in 1977. Person 2 is born in 1985, 1953, and 1997. So we know visually just looking at this, at these tuples, we know that person 3, which is Mary, has the oldest date of birth. So now we create a list from these tuples of peoples, and when we print when we call the function oldest person and pass the list of tuples, right, it should return the name Mary. So that's what we're going to work on next. Okay, so let's open this up. We're going to copy this, and we're going to, for testing purposes, if name is equal to main, like that, then we're going to define the function called oldest person, which takes in a list of people and returns a string. Then we're just going to say oldest is equal to people as 0, 1. Then we're going to say for person in people, if person 1 is less than oldest, then oldest is equal to person 0. Oh, I'm sorry. We need the name. So we're gonna say name is equal to. Actually, I think we're gonna do a return early. Return person name. But okay, we're still getting this lint error here. So we're gonna say name is equal to none. And instead, what I'm gonna do is do name is equal to person 0, then return name. We're still getting an error. What happens if I just assign an empty string like that? So let's run this. Okay, so it does return Mary. Let's run our code in the test. We failed. The result returned by the function oldest person is incorrect. Function should return Arthur when executing the following code. Okay, let's test this with this. Still returns Mary. Okay, so it's only printing Mary here. So that means it's not returning the name. It's not setting the name and returning it. Okay, age is equal to person 1. If age is less than oldest, set the name. Okay, it's still turning 0. Okay, so this is, I think I realized what I'm doing wrong. So we're just doing one comparison, but we're not, if the current person that we're looking at, their age is older, then we need to set that as the oldest. So we need to come down here and say oldest is equal to age. And since we're already assigning the first person's age as the oldest, then we can also do it the same thing for the name. So we can just say people 00, like that. So now this, I think, should return Mary for this first list, and it should return Arthur for this second one. And there we go. We get Mary and we get Arthur. So now when we run this through our tests, we succeeded. We can send that solution to the server. And you go to the browser here, refresh. There we go. We got credit. And we can also open the model solution in the browser. And there we go. So as you can see, in the model solution, it's a little bit cleaner than mine. But they have this variable oldest, which points to the first person. Now, instead of like what we did, for example here, we set oldest directly to the age of the first person in the list. And the first name from the list as well is assigned to this variable name. And then we just compare individual values per tuple, right? Because now when we're iterating in the list contains tuples, right, from down here. And so we're comparing the values from each tuple directly. But in the model solution, they're comparing the values of the tuples in this way, right? They're comparing tuples to tuples. So the oldest person, let me say the oldest variable points to a tuple, which contains a name and an age. So now here for person in people, we're comparing the age of this person, right, of this tuple, to the age of this tuple, the oldest person that we've set. And then we can set oldest equal to that person and then return the name of the oldest person. So I like this solution even better than ours. It's a hell of a lot cleaner, right? I think this is what, like 6 lines of code. We did it in 1, 2, 3, 4, 5, 6, 7, 8, 9 lines of code. So their code is just a little bit cleaner than ours. And I like this approach a little bit better, right? You're comparing tuples values like this directly instead of getting individual values and then comparing those individual values afterwards. So I think that one's a better solution, but our solution works too. So just pick your poison. It's neither here nor there. Okay, here we have a third exercise called older people. It says in this exercise we're handling tuples just like the ones described in the previous exercise. We're instructed to please order a function named older people. Right? It takes in a list of people and a year. It selects all those people on the list who were born before the year given as an argument. The function should return the names of these people in a new list. So this is how an example. We create 4 tuples, P1 to P4, Adam, Ellen, Mary, and Ernest, with various ages. And then when we call older people, then we return a list that contains the names of the people born before they provide a year. So anybody born before 1979, which will be Mary and Adam, and it returns that list. So this exercise, at least in my head as I'm looking at it, I think it's pretty straightforward. We're going to define a function here called older people, which takes in a list of people and an integer for the year, and it returns a list. We're going to create a list in here called oldest, set that equal to an empty list, and we're going to say for people, for person, in people, if person, their age is less than the year, then oldest that append person's name, and then we return oldest. Now if name is equal to main, we can put all that stuff there. Let's run this. And we get Adam and Mary. Over here we get Adam and Mary. But for testing purposes, I'm gonna do another one. Print, and let's get John from 1962. We get Chris, born in 1991. We're gonna get I don't know, Emily. She was born in 1975, and we'll get Lorenzo, and he was born in 2000. So actually, I need to wrap this in the function call for older people, like that, and we need to give it a year. So our cutoff year is going to be, you know, we'll do 1970, right? Because let's see if it just gives us John, and it does. Okay, so that means that works. Let's move the cutoff to above Emily's age, so we'll do 1976. See if we can get Emily involved as well, and we do get John and Emily. And let's set the cutoff year to 2000. So we know we should get everybody but Lorenzo. And there we go. So this should be the solution. So let's run our tests. And we did pass, send the solution to the server, show the model solution in the browser. And yep, they did the same thing that we did, right? Create a helper list here, a tracker list, and then loop through the list of tuples, right? People. So if the person's age is less than the provided year, then append that person to our list and then return that list. So that's it. There's nothing fancy to do here. That's the solution. Yeah, that was pretty simple. So we can refresh this, get credit for that, and we are making good headway. Okay, what is the purpose of a tuple? Now, tuples are ideal for when there is a set collection of values which are in some way connected. For example, when there's a need to handle the x and y coordinates of a point, a tuple is a natural choice because coordinates will always consist of 2 values. Which is, I was just about to start yapping about this, but yeah, technically it is of course possible to use a list to store these as well, right? If we know that the structure of a given data type, that a custom data type, for example, if we're working with coordinates where we need an x and a y coordinate, then yeah, we can just do lists with just 2 integers because we always know that the first integer will be the x coordinate and the second integer will be the y coordinate. A list is a collection of consecutive items in a certain order. The size of a list may also change. When we are storing the coordinates of a point, we want to store x and y coordinates specifically, not an arbitrary list containing those values. Because tuples are immutable, unlike lists, they can be used as keys in a dictionary. The following bit of code creates a dictionary where the keys are coordinate points. So here we have a dictionary called points, And for points, we are appending, right, the keys. So the keys in this dictionary will be a tuple called 3, 5, and that will be mapped to the value monkey. Then here we have another item added to the dictionary with the key 5, 0, right? The key is a tuple, and that's mapped to the string banana, and so on and so forth. So when we print what the value mapped to the key tuple 3, 5 is, it's going to return monkey. But if we're attempting a similar dictionary definition using lists, it will not work, right? Unhashable type list. And I wish I would have explained this a little bit further. So give me 1 second. Let me just see if I have this in my notes. So actually, wait, I meant to open the Python. Okay. So we know that this works. We can run this and it will work. It's going to print monkey. So why doesn't this work? And I'm going to comment this out. Why doesn't this work? We're going to get that type error, unhashable type list. So when we first learned about dictionaries, right, in the previous videos, we learned that dictionary keys are immutable, meaning that first they have to be hashed. They have to be, there's some conversion that happens to store that key so we can reference it later. So that's why keys have to be immutable. That's why when we do, for example, in a dictionary, right, if we were to do points, for example, Andrew is equal to Alson, like that, I can't then do points Andrew is equal to, I can't overwrite this. I can't change the name of the key in the dictionary. That's the point that I'm going for. So this works because tuples are immutable. As we've learned earlier, we can't do points, right? I'm sorry, if we could create point is equal to 3, 5, I can't do point 0 is equal to 4, or like this, right? I can't change the value of 3 to a 4 by targeting the index that appears in the order of our tuple. I can't do that, right? Tuples are immutable. So that's why this doesn't work, because lists, right, in order for them to be keys, sure, you can set them as keys, but the problem is that this can't change later on, right? And an easier way to see this would be to actually do this. We'll set key equal to a list of 3, 5. Then we'll say points at key is equal to Andrew, like that. And let me clear this. Right, it's gonna get to the same error because, right, if say for example, if I could do this, if this was valid Python code, well, what's not stopping me from going from later saying key 0 is equal to 1, right? So now, if this did work, then points wouldn't be 3, 5. It would instead be points 1, 5, right? But because the key for a dictionary has to be hashed so that we can reference it later when we want to retrieve the value that it points to, well, then I can't do this because lists are mutable. I can change the contents of a list. I can change specific indexes, the values in specific indexes. So that means I can never hash this because Python has to be able to go back and update content in the list. So I can't use it as a key because keys are supposed to be immutable in dictionaries. So hopefully that makes sense. The reason why this works using tuples as keys for our dictionaries is because tuples are immutable. I can't change the contents of what's inside of a tuple so that when Python hashes that tuple, it will always point to the same content, right? It will always reference the same hashed item that points to the value that key points to, right? Is referencing, or is mapped to, I should say. But because lists are immutable, lists, I can change the contents of a list, that means we can't hash it the same way. Because in the future, if I go back and change what items are in the key, right? If I spot change the value of a specific index, then that means when the dictionary is created, then that hash is useless. The original hash is useless. So we can never point to whatever it was mapped to um, because this key has been changed now. The values of the keys have been changed. So that's what this error is. Essentially, because lists are mutable, right? I can update the contents of a list, then we can't hash it. Because then when we do, if we were to hash it, and then we were to go back and change what the contents of a list are that is set as the key of a value in a dictionary, then we can no longer reuse that hash value. So hopefully that makes sense. I'm surprised that they didn't explain this further, but I guess it's sort of building on your context, right? From what we learned in the previous video about dictionaries, this is why this doesn't work, right? We can't hash lists in relation to dictionaries as being dictionary keys. Okay, hopefully that helped out. Okay, tuples without parentheses. The parentheses are not strictly necessary when defining tuples. The following two variables assignments are identical in the result. So here we have a variable called numbers, which is assigned the definition of a tuple that we've seen so far. We use an opening and closing parentheses, and then that wrap whatever content that we want to place inside the tuple. But this also works, right? I can create a variable called numbers. As long as I have comma separated values like this, then Python would treat numbers as a tuple. So in fact, if I go here and I say numbers is equal to 1, 2, 3, and I was to print type numbers, then we get class tuple, right? But then if I was to do print type 1, 2, 3, I'm sorry, this should be, I think it would be easier if we do numbers 1 is equal to 1, 2, 3, and then print numbers 1, we also get a tuple. So these two lines of code are doing the exact same thing. You can see that Python treats them exactly the same. As long as you have comma separated values, then Python treats them as a tuple. In fact, even this will work, right? Also get a tuple. So this means we can also easily return multiple values using tuples. Let's have a look at the following example. Here we define a function called min-max, which takes in a list. Then we'll return the minimum from our list and the maximum from our list, but it will be returned as a tuple. Remember, comma separated values like this, Python will treat as a tuple. So now when we test this, we can extract the two values from the return tuple of our min-max functions. So let me copy this, paste this in here, and you can see the smallest item is 5 and the greatest item is 312 from here. So we can extract values from a return tuple using comma separated values like this. So minimum, so we have a variable here called minimum value and another variable called maximum value separated by commas. And here we get from calling the min-max function and passing our list, then we can extract the minimum value, which will be 5, and the greatest value, which will be 312 from here. So we can return tuples like this, right? Another way I would have been able to do it would be to say, hey, smallest is equal to min, my list, and largest, I should say greatest, is equal to max, my list, and then return smallest, comma greatest, like that. So that will be a tuple, right? That will be a valid return statement. We'll just comment this out. This will also be a valid return statement, like that, right? So Python treats this as a tuple, it treats this as a tuple, and it treats this as a tuple. So we can return this as well. Right? Actually, we can't return 3 statements, so pick your poison and then keep it. So we can do this, right? This will be valid, or we can get rid of this and we can return one of these like that. So we can do these 3, or we can comment that out and we can return this, right? So as I mentioned, these two are a tuple, right? Comma separated return values. We can be very explicit in showing that we want to return a tuple by wrapping our values in opening and closing parentheses. And we can just do something similar to this, right? Instead of assigning separate variables and calling the minimum and maximum functions, we can just return the return values from calling our minimum and maximum functions separated by commas as the return from our function. So this is why that works. This function returns two values in a tuple. The return value is assigned to two variables at once, so minimum, maximum values. So if you ever wanted to declare two variables at once, this is how you do it. And then using parentheses may make the notation more clear, which is what I was just talking about if you want to be more explicit. On the left-hand side of the assignment statement, we also have a tuple which contains two variable names. The values contained within the tuple returned by the function are assigned to these variables. So I'm assuming what that means is that this is also valid code. So let me just scoot this over a little bit like that. So we can do it this way, or we can also do it this way. And this is also valid. They were saying, hey, this tuple with the values minimum, maximum are like that. You may remember the dictionary method items in the previous section. We use it to access all the keys and values stored in a dictionary. So here we create a dictionary with no keys and values. Then we assign a couple of keys and their mapped values. And then we say for key and value in dictionary items, then we can print the key and then print the value. Right? So here, this is a tuple, right? This is a tuple, comma separated values. So that's what this returns. So the method myDictionary.items returns each key value pair as a tuple where the first item is the key and the second item is the value. So another common use case for tuples is swapping the values of two variables. So we can do this. We can have, say for example, number one, number two have integer values. Then but we want to swap them around. So that instead of doing manual assignment, we can just do it this way. We can swap them around. So number two will be assigned to the value number one. Number one will be assigned to the value number two, and number two will be assigned to the value of number one. The assignment statement above swaps the values stored in variables number one, number two. The result is identical to what is achieved with the following bit of code using a helper variable. So like here, when you manually do it. Okay, so here we have one of our last two exercises called student database. Some exercises have multiple parts, and you can receive points for different parts separately. You can submit partially complete exercises by choosing submit solution from the menu context. In this series of exercises, you will create a simple student database. Before diving in, please spend a moment reading through the instructions and thinking about what sort of data structures are necessary for organizing the data stored by your program. So part one, adding students. Please write a function named addStudent, which adds a new student to the database. Also write a preliminary version of the function printStudent, which prints out the information of a single student. So these functions are used as follows. We have a dictionary here called students. We call addStudents to the dictionary, and we pass the dictionary and the name Peter as arguments. And we do the same thing for Eliza. Then we can print those. So this is what it should print out. So Peter, no completed courses. Eliza, no completed courses. And then Jack, no such person in the database. Okay, so let's go to VS Code. Open the file and define a function called addStudent, which takes in a dictionary. So we say students and a name, which is a string, and it doesn't return anything. All it does is do students name is equal to the name like that. Then we define a function called print student, takes in a dictionary of students and a name, and all it does is print student's name, and then also print, I should say if students, if name in students the items let me just look at this one. No completed course. and print name, and then print no completed courses, else print name, no such person in the database. Like that. I'm gonna copy this. If name is equal to main, let's run this. So Eliza, no completed courses, Peter and Eliza, and then Jack, no such person in the database. All right, how many spaces is it? Just one space? Okay, so we'll just do one space. Okay, so I'm assuming that's complete. That part. You know what? I'm gonna stop the video here. I'm gonna do these last two exercises in the next video. As much as I don't want to, I think that would be the correct approach. So I have some time to think about this just a little bit more, and then we will be able to address these two exercises. There's only two exercises left in this section, so we should be good to knock this out in like 20 minutes in the next video. So stay tuned for that. It'll be uploaded basically right after this one. They should be uploaded together basically, so you can watch them in tandem. I mean in sequence, and be done with that. So this will be the last, video on reading material from section 5, and then the next video will be covering the last two exercises, and we'll be done with part 5, and then the video after that will be starting part 6. So I'll see you guys in the next video.